In this video, we will be investigating combining random variables. First topic, changing a random variable by a constant. Much like before when we talked about means, and means are expected values, if we have some expected value of some random variable x and we want to add or subtract some constant number c, then this new mean is simply going to be the old mean plus that constant c. Just as we said earlier with data, the random variable behaves the same way. We add some number to that random variable, it's just the previous mean plus that constant. And also, like with our spread variance, an add does not change it. If we have the variance of some random variable x and we add or subtract some constant, it's simply going to remain the old variance. And we saw the same thing with standard deviation of data. Adding does not spread the numbers out, it simply shifts them. So whether we add or subtract some constant, the variance will remain the same. When we multiply, the mean, the expected value, by some constant x, it's simply going to multiply the previous expected value by that constant. Now, here's one that might look slightly tricky. When we have our variance of some constant times our random variable, this is going to equal the square of that constant times the previous variance. Okay, and before your head explodes on this one, just keep in mind that standard deviation is the square of variance. So this really makes sense. If we took the square root of both of these sides, we would have the standard deviation of this quantity would be that multiplier times the standard deviation, which is exactly what we said before. Recall when we were dealing with data, if we multiplied each of the data values by some number, the variance was, the standard deviation was multiplied by that number, and that's the same thing we see here. I'm going to write this as a standard deviation, and you'll see that the standard deviation, the analogous statement here, the standard deviation of a times x is simply equal to that value a times the standard deviation of x. Okay, so these two formulas here are equivalent. Same. Okay, one is for the variance and one is for the standard deviation, but as we know, the variance is simply the standard deviation squared. This statement is simply the square root of this. This statement is simply the square root of this one. Okay. Addition rule for expected values. If we have the expected value of some random variable x plus some random variable plus or minus some random variable y, it is simply the expected value of the random variable x plus the expected value of the random variable y. Again, the means are behaving just exactly like we think they would. If it says, should say add or subtract here. If it says add, we will add. If it says subtract, we will subtract. Now, the variances are going to behave a little bit differently. Addition rule for variances. If x and y are independent, okay, so if they're not independent, this rule doesn't hold. Then the variance of x plus or minus y will be equal to the variance of x plus the variance of y. And this is different than here. Here it says plus and minus, plus and minus. Here, whether we're adding or subtracting, the variances will add. So if the variance is written in this fashion, I can write the standard deviation like this. Again, this is an equivalent statement. The standard deviation of x plus y, x plus or minus y, I've simply taken the square root of this side, so I'll take the square root of this side, is the square root of each of these variances. The variance of x plus the variance of y. In this formula here is often called the Pythagorean theorem of stats. These two, the Pythagorean theorem of statistics. And remember what the Pythagorean theorem says. It says a squared plus b squared is equal to c squared. Stated another way, I could say c squared is equal to a squared plus b squared. And that's essentially what this statement is. Remember, variance is a quantity squared. So this variance of x plus y, this statement here, I could rewrite as variance, I write it as a quantity squared of x plus y is equal to the variance of x plus, those are like g's I've written there, variance sigma squared. Okay, so here you see this is like my c quantity, and that's the square of my a, and that's the square of my b. So and if you think about it, it makes sense, because what is variance? It's a measure of spread. It's a distance. And what is the hypotenuse but a distance? So the fact that these two are analogs, it does indeed make some sense. From your textbook, there is an example and an explanation for this first one on page 395. Page 395 for the both this expected value and variance for these multiplications of a constants. There's one on page 396. For the expected value as well, there's one on page 396. And for the combining of the random variables, you can see this on page 396. All right, with these notes, you should be able to handle the rest of these problems.